Okay, let's take a look at this statement, which says, I can recognize that displacement is not always equal to the distance traveled. Let's go ahead and recap real quick on what these two words mean. Displacement is the change in position. We could make maybe a more exact definition, but essentially displacement is the change in position. Distance is the total ground covered. Okay? Those are the basic definitions for both displacement and distance. Okay, now let's take a look at maybe 3 different quick examples of how displacement is not always equal to distance. All right, let's maybe start off by drawing a quick picture of your house. Okay, quick layout. Here it is. All right, there are several hallways in your house. Okay, here's a hallway. And there's several rooms. Okay, so this is like a bird's eye view of your house. Now let's say for a second that you are just getting ready to leave. You're right here. You're just getting ready to leave your house, and oops, you forgot your cell phone, and you realize you don't know where it is. So what do? You start running around the house trying to find your cell phone. Apparently you're running through the walls at this point. But you run around, you run around, you run around, and finally you find your cell phone right here at this point. Okay? Now the distance is the total ground you covered with this dotted line right here. Displacement, however, is just your change in position. Realize all you changed from position was here to here. So this space right here would be our displacement. Almost like the shortest distance, I guess you could call it. But again, it's supposed to be your change in position. All right, let's take a look maybe at another example. If you remember from class, we talked about a running track. Okay? So here's a running track, or what's supposed to be a running track. And let's say that you are standing right here at this point, and you're getting ready to run around the track. Okay? So you start, you go. Okay, this dotted line represents you running around this track. Okay, and as you would probably agree, okay, in this case, this is going to be your distance because this is the total ground, this dotted line that you covered. However, in this case, your displacement, okay, is actually 0 because you did not change position. You started here, you went all the way around, and you ended up at the same reference point. So your displacement here is 0, but your distance is this blue dotted line. It's the ground that you covered. Okay, let's take a look maybe at one more example, maybe on a position versus time graph. So here will be time, this will be position. Okay, and let's say for a second that you decide to move away from something. Let's say it is your teacher. Okay, so you move away from your teacher 5 feet, we'll say. Okay. Then you talk to your teacher for a while, for a few seconds. And then you move back away from your teacher. Let's say again that distance toward the teacher was 5, and the distance away from the teacher was 5. Okay? Now, let's take a look at what your displacement and your distance would be. Okay? Now, again, displacement is change in position. So if you started at a position of 0, and then you end it at a position of 0. In this case, just like the case before, your displacement is 0. But the total distance you covered is different. Okay? You went 5 feet toward your teacher, you stopped, and then you went 5 feet away. So in this case, your total distance cover would be 10 feet. Okay? So there you go. That is 3 examples, 1, 2, and 3, of when displacement is not always equal to the distance.